What we saw was that, wow, under catastrophic conditions, things like rock layers can actually form very, very quickly. So let's take a look.
On May 18, 1980, Mount St. Helens, located 95 miles south of Seattle, Washington, erupted. The eruption was triggered by an earthquake centered beneath the mountain that measured 5.1 on the Richter scale. The lateral blast swept out the north side of Mount St. Helens at 300 miles per hour. With temperatures as high as 660 degrees Fahrenheit and the power of 24 megatons of thermal energy, it snapped 100-year-old trees like toothpicks and stripped them of their bark. Before the famous eruption at Mount St. Helens, scientists were mostly familiar with slow-acting examples of geologic change. But at Mount St. Helens, geologists watched the Earth's surface change quite rapidly. Icebergs were buried in hot avalanche material. They melted and formed badlands in days. Eruptions on May 18 and June 10 produced fine layers in hours. On June 10, mud flows cut zigzag canyons 100 feet deep in soft sand and mud, complete with perpendicular side canyons. Canyons that are reminiscent of the geography of Grand Canyon, only 40 times smaller and clearly produced within hours. Mud flows over the following decade cut hundreds of feet into solid rock in just days of cutting time. Fallen trees formed a log mat on the surface of Spirit Lake and dropped bark to the bottom of the lake, accumulating up to 3 feet of bark peat in just a couple years. And vertically floating logs sinking to the bottom of the lake resulted in buried trees in only a decade, similar to the trees of Yellowstone's fossil forest, which are also buried in volcanic layers. Even though Mount St. Helens is a very small catastrophe compared to the flood or the major catastrophes immediately following the flood, it provides a better clue to what happened in those times than the slow geologic processes which are most commonly seen in the present.
Okay, so what this showed was that under catastrophic conditions, you can get a lot of change in a short period of time. They showed these rock layers that were here. You see the person at the bottom for an idea of how big, how many rock layers are there. Those rock layers were formed in a matter of hours. It did not take millions of years. All it took was the right condition. They talked a little bit about this canyon. This is called Engineer's Canyon. It's 1/40th the scale of the Grand Canyon. It was cut out in 9 hours. That's all it took, right? It just took a catastrophe. Now, there's a little river that runs through that canyon. And I'm going to tell you right now, that river didn't make that canyon, right? Because we know. We observed it in the present. It just took 9 hours to carve that out. Now, I would say the same is true for the Grand Canyon when you go there. Now, when you go there, they'll tell you the Colorado River carved that out over millions of years. Nope, it did not. There's no way. It would not look like that. It looks a lot like it happened very, very quickly, not that long ago. One of the evidences of that is the fact that the faces of the canyon are very steep, okay, and they don't look like they've been weathered away for millions of years, right? They're much more recent because they're the result of probably a post-flood catastrophe that carved that out in probably just a very short period of time as well.